This is a reassessment of the standard on Newton's second law. The problem I chose is number 72 of chapter 3 on page 115. And a man lifts a 2 kilogram stone vertically with his hand at a constant upward acceleration of 1.5 meters per second. What is the magnitude of the total force of the stone on the man's hand? So we have labeled our mass of our stone, which is 2 kilograms, and then we labeled our acceleration, which is upward, which is 1.5 meters per second squared, and because it's upward, that means that it's positive. To begin, we start with Newton's second law, which is force is equal to mass times acceleration. Now, because the stone is being lifted by the man, there are only two forces acting on the stone. There is the force exerted by the man on the stone, and then the gravitational force, which is pulling it down. So, because these two forces oppose each other, they will cancel out, and so that is why you can substitute, or they will equal the force, and that is why you can substitute mg into the F equals ma equation. So you put F minus mg is equal to ma, and then you add mg to both sides, you get F is equal to mg plus ma. Then you factor out an m, and you get m, open parentheses, g plus a, close parentheses. So then when you're here to find the force, you just plug in your unknowns that you have. You have the weight of, or the mass, excuse me, of the stone, which is 2 kilograms. And then you have the gravitational force, g, which is 9.8 meters per second squared. And then you have the acceleration, which is 1.5 meters per second squared. And so you will add those together, you get 11.3 meters per second squared. Multiply that by 2 kilograms, and then your force is equal to 22.6 kilograms times meters per second squared, or 22.6 newtons, which if you round up will give you a force of 23 newtons in the direction downward, which is the force of the stone exerted on the man's hand, which is what the problem asks for.